In this video, we're exploring Home Assistant Build CLI, a command line interface built by the creator of Home Assistant himself, Paulus Schoutsen. While anyone can use it directly, Home Assistant Build CLI was designed from the ground up for LLMs and AI agents. This allows AI to talk directly to your system and automatically manage everything in your smart home, from writing automations and designing dashboards to complete system maintenance. If you're running HAOS, getting started is shockingly simple. You just head over to Settings, go to Apps, add the repository URL, and hit Install. You'll quickly notice this is the OpenCode repository, which has the Home Assistant Build CLI completely built in. Once the installation is complete, click Open Web UI, and you'll find that the Home Assistant MCP tool immediately shows connected. The moment it's active, it automatically establishes a direct, secure bridge with your Home Assistant instance, leaving you with no long-lived access tokens to manage and zero manual configuration. It just works right out of the box. I reviewed the feature list and found Home Assistant Build CLI highly versatile, covering nearly all Home Assistant management tasks. To make it easy to follow, we're going to focus on 7 core categories of functions. First up is device management. This category serves as the foundation for how the AI understands your smart home, allowing it to retrieve comprehensive snapshots of your setup, check device histories, and analyze how different areas and entities relate to one another. For example, if you type "list all entities assigned to bedroom area" in the chat box, the AI will translate that request and automatically call the HAB entity command to retrieve and display everything in that specific zone. Next up is automation. This category enables the AI to control the active behavior of your smart home by calling services, writing scripts, activating scenes, rendering Jinja templates, and configuring routines from scratch or from pre-existing blueprints. To test this feature, I entered "Create an automation that turns off the smart plug at 11 p.m. every night." The AI first checked my existing configuration, identified the correct smart plug entity, and asked for my confirmation. Once I agreed, it indeed translated this request and automatically called the HAB automation command to program the precise triggers, conditions, and actions. However, when I first opened the automations page, I noticed it was empty, meaning OpenCode doesn't automatically reload the Home Assistant configuration to apply the changes. While this was a bit of a shame, once I manually triggered a reload and checked the page again, the new automation was successfully added without any errors. Overall, still a solid result. Third on the list is dashboard management. This category gives the AI control over your Lovelace interface, allowing it to build and modify dashboards. It can easily structure views and sections, position cards and badges, or directly edit raw YAML configurations. To see how this works in practice, I asked the AI to create a dashboard named Bedroom Dashboard and add our smart plug to it. Because the smart plug has multiple associated entities, the AI first identified them and asked me to clarify which ones to include. I chose to add the main socket switch only. Behind the scenes, the AI checked the command schemas and called the HAB dashboard create command to set up the new dashboard, and then automatically added a tile card for the smart plug switch. If you look closely, as soon as the creation was complete, this new dashboard appeared right in the sidebar. When I clicked in to check, everything was displayed properly and worked as expected without any issues. The fourth major category is helpers. This allows the AI to set up virtual entities like input toggles, timers, and utility meters. The agent can easily configure simple variables, perform complex sensor group calculations, or build custom sensors backed by Jinja templates. For a quick test, I requested "create an input Boolean helper called presence with a toggle switch icon." The AI analyzed the request, verified the parameter syntax, and called the HAB helper command to configure the entity. When I opened the helpers page in my settings to check the result, the new toggle was right there, set up exactly as requested, without any issues. The fifth core category focuses on schedules and alerts. This gives the AI the ability to manage your calendars, coordinate tasks, and send system notifications. The agent can query or schedule calendar events, track and update itemized to-do lists, and easily create or dismiss persistent on-screen alerts to keep you informed. To test the alerts, I sent a request saying, send a notification titled Backup, saying Backup completed successfully. The AI translated this and called the HAB notification command to generate the alert. Right away, the notification panel popped up with a badge showing one new alert, and when I opened it, the message content matched what I asked for without any issues. The sixth area of capability is operations and maintenance. This set of tools provides the AI with deep system access to keep your setup running smoothly. The agent can monitor system health, manage backups, check diagnostics and network configurations, reload integrations, and even execute configuration checks or system restarts. When I asked, can you check my Home Assistant system information? The AI immediately called the HAB system command to query the core. In seconds, it presented a tidy breakdown of my setup, including the software version, running state, location settings, and safe mode status, giving me a clear overview of the system's health and active integrations. Finally, our seventh category is ESPHome. This module allows the AI to manage your custom microcontroller devices directly through the command line. The agent can search the community hardware catalog, generate or edit device configurations, validate builds, and even compile or update your nodes remotely. For a final test, I asked the AI to search the ESPHome catalog for ESP32-based smart plugs that use relays. The AI immediately processed this request, calling the HAB ESPHome catalog command to scan the directory. In seconds, it returned a structured list of compatible devices, ranging from pre-flashed options like the Atham V3 to community configurations from Shelly and Sonoff, complete with details on their internal relays and power monitoring features. By the way, I've put together a document summarizing everything from this video and all of our past videos, link in the description. Let me know in the comments what you think of this AI-driven builder. As always, your likes and subscribes keep me going. Thanks for watching.